Welcome to this session for understanding Terraform, which is a cloud orchestration as a code. I'm your trainer, Bhaskar. I have around 10 plus years of experience working as a senior solution architect for cloud on DevOps in a top IT MNC company of India. I'm taking this session on behalf of Study9, which is a Bangalore based e learning startup which focuses on bleeding edge information technology topics like Terraform, and other topics like AI, DevOps, cloud computing, etc. For this particular course, there is not so much of a prerequisite, but some prior understanding of cloud computing would be good enough. First of all, let's talk about the basics. We will start with the fundamentals about the cloud and where exactly Terraform fits. So, in a nutshell, what is Terraform? Terraform is a hybrid cloud API orchestration tool that can be controlled through code. So there is no GUI as such. It has a coding language. You have to write up some program, and using that program, you can orchestrate a hybrid cloud environment using the hybrid cloud API. Now, to understand this better, let us break it down to the components. Hybrid cloud API, right? So what are these things? So cloud is a set of traditional data center services like storage, network, compute, middleware, databases, applications, all of these things provided to you and me over the internet or some large scale network on a pay as you go basis. So we pay by the hour, pay by the minutes, pay by the seconds of usage, or pay by the monthly usage. Whatever we do, whenever it is a networked service given to us for our storage, email, all this stuff, for which we pay by unit rate, that's kind of what is known as cloud computing in the IT technology domain. So you can think of a Gmail or a Google Drive as cloud-based email services or cloud-based storage services. What is a public cloud? So this Gmail or Google Drive, which are cloud services given to us over internet, and the actual data centers are some faraway location, and we are only accessing it over internet and paying for the extra users that we are making. Like, let's say there is a limit on your Google Drive. If you want more storage space, you have to pay Google in order to get that storage space. So when we have services like that, where we can buy extra storage over the internet from a third party provider in a cloud kind of a model, we call it as public cloud. This is something we are very familiar with. The second type is the private cloud. This is something that in general people who are not working in an IT industry would not be so much familiar with. So internally within a company, also we require the storages, emails, and network, computes, all this stuff. Now, in an IT company, when there is a separate organization created, which is supposed to handle all this compute, storage, network, email, all these services, and provide to all other business units on a pay as you go model, then that is also known as a private cloud. In this case, a cloud is built within the organization. One particular business unit owns it. All the other business units are then customers of that particular business unit from where they get all those services. And these other business units would pay per usage basis. So if somebody using more storage, he will pay more. Somebody using less storage, he will pay less, right? This is a cloud economy model implemented within the business. And obviously, the cloud also has to have the cloud-like characteristics, such as it has to support an API, it has to support a pool of compute, pool of storage, all these elements in order to address the need of various business units. Hybrid cloud is when you have both of these types available within your company. So there is a business unit which is having a technical cloud implemented from where they are delivering certain services, but still all of your users are actually going to internet for using some of the other services from the public cloud providers. A very common example is, although the internal IT organization of a company may be giving you storage, compute, and network services, there is a email service which they're not doing, but rather is taken from something like a Microsoft Office 365. So Microsoft Office 365 is not an Exchange server implemented within your company, but rather is an Exchange server implemented on the Microsoft data center, and you're accessing it over the internet. While you are not individually paying for it, your company is obviously paying for it to Microsoft on a pay-per-use basis. So when you have such a scenario where there is a private cloud which your organization runs, and you take some services from there, and there is a public cloud from where your organization and you take some services, then you are a user of both private cloud and public cloud. This kind of a scenario is known as the hybrid cloud. Now, while talking about this cloud computing, I have said that there is something called API. So we need to understand what this API means. So when you're doing things on cloud, you can either use a GUI to access those components. Like, let's say on a cloud computing environment, you want to buy more storage. So you can go and click on a button called buy more storage and make payment and buy the amount of storage that you want. Some of these cloud solutions also provide you a CLI. So instead of going to a browser and doing all this stuff, you can actually open up a CLI, run some commands to connect to the cloud, and from the command line itself, you can request for more resources to be allocated to your machine. Now, in this case, obviously, the payment related stuff has to be handled separately, but at least the storage allocation and all this can be done through running the CLI. Now, these are the interactions that you as a human being would be doing with the cloud. Now, what if there are two applications which need to interact and do a similar stuff? For example, let's say there is a particular monitoring tool that you have taken from the cloud, and this monitoring tool needs to send an email whenever there is an issue happens. Now, this monitoring tool needs to communicate to the email which is provided by Microsoft Office. Now, at that point, if Microsoft Office have an application programming interface, then using that interface, this monitoring tool can call the email service to send you a mail if, let's say, a server went down, right? So monitoring tool is monitoring certain servers. The server has gone down. The monitoring tool wants to update you as the administrator of that server. So the monitoring tool will reach out to the application programming interface of the email service which you have taken from, let's say, Microsoft Office, and tell that this is the email that this server has gone down and you need to send it to so and so person. The email server, upon getting that request over the API, will send you that email. Now, this transaction happens between two applications, and to enable this, both these applications need to have a application programming interface. For example, the email server also would like to send back a confirmation to the monitoring tool that the email was sent, and that it can do if the monitoring server also has an API. Now, every cloud solution has their own API, and it's different for various cloud solutions. Before we get into the hybrid cloud APIs and the problems related with them, let us understand what at all is called orchestration. So as you can see in this particular picture, we are having an orchestra. The fact that all these people together are creating a music by coordinating themselves in a certain fashion is known as orchestration. So who is the orchestrator? Everybody is following the instructions of the person standing in front of them with a stick in his hand. That person is guiding the entire team on who needs to play what at what point of time. And then the orchestra happens. The whole music gets created. This person who is responsible for running the entire coordination is the orchestrator. In case of cloud computing solutions, there are tools which can similarly have all these different components of cloud orchestrated that is coordinated in a certain fashion to achieve an objective. For example, let's say you want to launch a virtual machine. The virtual machine first would require some storage from the backend storage server. It would also require a computer to boot up from. It would require an operating system from an image library. So the orchestrator would call the operating system image, would get a storage provisioned, would boot up the operating system image on top of that storage on a particular computer machine that it has selected. And once it has booted up, it will also initiate certain application installations on top of the VM. The step 1, step 2, step 3, step 4 of doing this is written up inside the orchestrator. An orchestrator accordingly instructs every other component of the cloud. It calls storage API, image API, compute API, application installation API, all at the right point of time to make the whole thing work. Now, this API orchestration of the cloud can happen in two ways. There can be a GUI software where you can drag and drop things into a workflow kind of. Let's say first you call the image, second you call the storage, third you boot up a image on top of the certain compute and use that particular storage which is provisioned in the previous step, and then when the system boots up, install so and so stuff on it. You can put them in a graphical UI, in a graphical workflow, or you can have a coding language where you specify these steps. So if you are doing it using coding, obviously it's going to be called Cloud API Orchestration Coding. Now, there is a specific type of coding called declarative coding, and that's what is important to understand for our Terraform part. So if you're, let's say, having the requirement to go to your city's airport, I'm giving a similar kind of a situation from a real life environment. Let's say you want to go to the airport. There are two ways you can do that. One is you have to take your own car and drive it to the airport. In that case, you need to yourself handle all the obstacles that come in your way and all the path choices that come in your way. You can take a short route, which is maybe having a lot of traffic, or you can take a long route, which may have less traffic. Choice is yours. You have to make the choice. When you also do this, you have to also face the problems in the road. When the traffic increases, you have to pace it accordingly. When the traffic decreases, you have to pace it accordingly. You have to handle all the road conditions all by yourself. This kind of a model is where you are the person defining how the experience of you driving to the airport happens and how do you achieve that state that you have reached to the airport. Second option for you is to take a taxi, like a Uber. In that case, you sit in the taxi and you specify the destination in the Uber app, or just tell it to the driver that I want to go to the airport. When you do that, the driver takes you there. He handles the problems with the road conditions. He handles the problems with the various types of traffics in the road. So the definitive type of coding is something like a Ruby or a Python, where it is a general purpose programming language and you have to specifically write each and every step to say what you exactly want to do with the cloud or the cloud APIs. In this case, you have to know what is the process and how things work on cloud, convert them into an algorithm, write them like a coding language by using the coding knowledge that you have. And in this case, these steps are going to be absolutely low level steps. You have to define each and every task. Like if you want to open up a file, you have to say first open the file, then write code into it, then save the file contents, then save the file handler, close the file handler, and then finally you're done with file writing. Whereas in case of declarative coding, what happens, you are working with a tool that already knows how to work on cloud. So you just instruct it. The actual command, what needs to be run on top of that cloud, what is the exact API call, you don't need to know. Tool will know that. So you simply say, I want a Linux VM, and the tool creates Linux VM for you. If you are doing it on top of, let's say, a definitive coding, you have to supply more information. You have to actually walk through the entire API calls. You have to know what exact API call it is to make this happen. And then you have to call it from using Ruby or Python. You don't have to do it if you're doing it using declarative coding. Much like that Uber taxi, where you simply state your desired end state and the tool will take you there. You say, I want to have a Linux VM, the tool will create the Linux VM for you, while handling all the coding, all the API calls, everything by itself in the tool. Now, when a tool needs to do something like this, the tool needs to know all the API calls of a particular cloud. What happens in case of hybrid cloud is that every cloud has a different API. So here, a tool needs to know all the different types of APIs. Going back to that orchestra example, it's not like your orchestra has only violin players. Instead of that, it has different musical instruments played by different people. So the job of the orchestrator here is much more tough. He needs to have a good control on how to orchestrate the entire team. Similarly, a hybrid cloud management tool has to know all the API calls of different cloud providers. These API calls keep on changing when the cloud service providers release new versions. The tool has to be constantly updated with those things. It has to handle different authentication mechanisms for connecting to different clouds, which also is a task that otherwise could have been very problematic had you been doing this using a definitive coding. But because you're using a declarative coding of something like a Terraform, that becomes much more easy. It's a single tool which is able to authenticate with multiple clouds. It has inbuilt functions for operating on multiple cloud APIs. It has a very declarative programming language to create the orchestration workflow, making your life a lot easy. So now that we have understood all these fundamental building blocks, how can you define Terraform? Terraform is a single tool with a simple declarative coding language which has functions and subroutines that can call and interact with various different cloud services APIs across multiple or hybrid cloud solutions, enabling the developer, that is you and me, to write cross-cloud orchestration workflows to automate work across hybrid cloud setup. Now, this cross-cloud orchestration is a very important stuff. Typically, a cloud environment also comes with its own coding language. Terraform is not the first coding language for doing cloud orchestration. Every cloud has its own native cloud orchestration coding language, like CloudFormation coding language for AWS. There is Heat orchestration language for OpenStack. However, the beauty about Terraform is it's a single coding language. Using the same coding language, you can orchestrate both AWS or Azure or OpenStack all together. So you don't have to have people who have to first learn one coding language for AWS, one coding language for Azure, one coding language for OpenStack. You just need to get one developer who is a Terraform developer and then ask him to do automation workflows on top of AWS or OpenStack or Azure. This is something which is very useful for deciding or designing your team. So when a company decides to build up a team of people who are going to manage cloud, and if they have a hybrid cloud kind of a scenario, it makes a lot of sense to get a Terraform guy onboarded so that this guy can do orchestration across the different cloud environments that you have. Also, nowadays, because Terraform is becoming kind of a very, very popular cloud orchestration language, even companies with a single cloud environment are also going for Terraform because in that way, they're protecting their investment. The code that you create on Terraform is something that can be easily customized or changed to suit, if need be, to run the operations on a different cloud as well. So there is a bit of vendor locking freedom also which comes if you do your orchestration coding on Terraform. However, everything is not hunky-dory in Terraform. There are some issues with Terraform for which people may not pick up it. First of all, it does not have a GUI. So if a company is looking for a very GUI-based solution, Terraform may not satisfy the need. But it's not trying to satisfy that need either. Terraform actually falls under something known as infrastructure orchestration as code, which is a kind of a domain of infrastructure as code. In infrastructure as code domain, people don't like to have GUI. Here, rather, they would have a coding solution which can be version controlled, which can be easily customized, or if need be, can be rapidly customized. That means you, let's say, have a variable which you have used at 1,000 places within the code. All you have to do to create a change in that code is to change the value of the variable. This is something which can be only possible with codes. For a GUI application, if you have 1,000 steps which need to be made changed, you have to actually navigate through your GUI to those 1,000 steps and manually make those changes. People who use codes, they love the way of doing things using your code. They don't like that slow process of updating when you have to use a GUI. Terraform is also easy to learn language. It's not very complex. So that's also one of the main reasons why Terraform is so popular, although it is not a Tosca compliant orchestration language. Tosca is a standard which is coming up very fast as an industry recognized standard for doing cloud orchestration coding. There are tools out there which are Tosca compliant. Terraform, as of yet, is not Tosca compliant. So that sometimes makes it non-compliant to the requirements that a particular company might have. However, it is going very strong for all those people where they can do the orchestration using coding and they're not bothering about Tosca. And it's a huge community. So that's a reason why Terraform is growing popular day by day, because a strong community can really drive adoption of a particular tool. In order to learn Terraform, there are a few things that a person has to know. Obviously, some basics about the cloud computing in general, and then knowing how to operate on a particular type of cloud, let's say AWS. Then you have to also understand how to authenticate with AWS and how does this kind of a authentication role-based access control works. After you have got access to the cloud, you have to write the cloud operation steps using the coding language of Terraform. So obviously coding language of Terraform is something that you definitely have to learn. Finally, all this infrastructure as code, all this cloud orchestration has a connection to DevOps. So you need to understand the DevOps connection as well. In the course from Study 9, we start off with the basics. We understand the core Terraform components, the fundamental concepts of it, and how does it generally work. We then jump into implementation of it, and after implementation, we start checking the way to write the code. The syntaxes, various examples. We do a fair bit of live programming to make ourselves very comfortable on the Terraform programming language. We would look into how to use cloud resources. So every component of the cloud, every API call is basically a resources that you can provision using Terraform. How do you manage the life cycle of such resources within Terraform is something that we will look into. Terraform can not only bring up various components on top of cloud, it can also run automation codes on top of it, or it can use external scripts. How do we use those is something that we'll cover in the script execution chapter. As I said earlier, understanding Jenkins would help us understand the connection of Terraform with the DevOps world. We will do a complete project in order to understand that. We will deploy a Java application on top of the VMs launched through Terraform. And this particular project will also have components like Elastic IP, components like automation through the host and modification on its servers. We will use Tomcat APIs to provision the applications. So it's a combined project across the DevOps use cases and the cloud use cases of Terraform. Obviously, as part of the course, for people who are new to cloud computing, we have a complementary set of classes for understanding cloud computing and understanding operations on AWS cloud. All in all, this should give you a 360-degree idea about Terraform and should make you very proficient to get your jobs done in your workplace, or if you're a person who are looking for a job, to apply into various companies and crack the interviews. Terraform is a very popular domain right now because, as I said, there is a strong community in the market and a lot of companies are using Terraform, hybrid cloud or otherwise, to manage their cloud environments. So as the cloud adoption increases, the adoption of cloud orchestration languages like Terraform also keeps on increasing. It's a very interesting domain, it's a new domain, a lot of job opportunities are there, and it's a very niche skill set. So I wish you all well to get into this particular domain. And not only that, we will talk about Terraform in this, we will also discuss various alternatives at the end of the course. So that not only Terraform is what you learn, you should also know about the ecosystem around it. And we will talk about the reasons why those tools and Terraform have a difference and how Terraform succeeds over them. However, after having this class, after having the concept of cloud orchestration as code, you can definitely take up all these other tools also and learn those other approaches as well. That was all for this particular session. Thank you for watching this. You can go to study9.com/p/terraform to get more information about Terraform and to get to see the self-paced training materials or the live online classes that we organize on behalf of Study9. Again, thank you for watching.